Okay, so we'll get started now. We're to further what we were in. My objective for the day is to get done with the portion that we are left with, so that this chapter, so far as theory and punching in illustrations are concerned, we ought to be through before of a long closure. You know that the closure will be of around 10 to 15 days, though we will be in touch. Yet, it'll not be a collate, it'll be on an individual basis. Though, it said, let me tell you, I can involve on correlative basis as well, provided you are all in huddle. Not taking liberties out there, this is presumably the last before of a gap of 15 to 20 days. Let's make the best of it. And let's see to it that a productive part is left with us so that we can indulge for the coming 2 fortnight time. Okay? Got it? So portion that we were in, 10 of you are in, right? The portion that we were in, it was a conservation of linear momentum. Last class we saw center of mass of different structure. We studied for what they call as negative mass concept as well, wherein you have certain portion of a wholesome scooped out. And accordingly, we are left with the remnant. We are asked to find center of mass of the remnant. We saw that part. We furthered it to conservation of linear momentum. And we solved 2 or 3 questions on conservation of linear momentum. We'll be furthering. I told you that one of the questions, the last one, was solved with an unconventional kind of a methodology. And unconventional, why? Because you'll generally not see that methodology being adopted. So that was unconventional. Those who have missed need to visit that portion for sure. Furthering it, what I do next is we'll punch in for questions and then move on to the fag end of this chapter, which deals with coefficient of restitution and collision. I'll come to that. Before of it, let us solve few questions. If you do have any doubt on the questions that you have solved based on the last class dispensation on theory, you may feel free to ask. If you don't have anything to ask, we need to get a few questions done to accrescent our preparation vis-a-vis last class theory. What shall we do? Do we have any question, class? Your individual doubts on the portion that we went through last class? Okay, if nothing much, then we can further with questions. Question number 1, write down. A track as shown in the figure. A track as shown in the figure has a mass. A track as shown in the figure has a mass capital M resting on it when it is given a thrust. When it is given a thrust making move the mass on the track with an initial velocity v0 as shown. Find the maximum height up to which the given mass, capital M, will rise post leaving track of mass small m, which rests on a smooth surface. Which rests on a smooth surface. Let me make you understand what the question is all about. First and foremost, there is no mention of friction. So friction is absent, is not to be seen partaking in this question, be it any surface. Second, there are two masses, they were initially at rest. At rest as seen from a frame fixed to earth. It was then we gave capital M a thrust, a force which led to an impetus, and that impetus is getting it moved on the track with an initial velocity of V0. Somewhere there will be a force or a component of force in the horizontal direction on a small m. Initially there will be none. Why? Because it's almost horizontal track. If I'm to show you up to what point there will be no force acting, let me show it by different color. This is a horizontal track. So up to this point, I don't think there is any objection. Up to this point, there will be no force or component of force acting on a small m in horizontal direction. So up to this point, small m rests easy. The track rests easy. It will not move. The track will not move. After of this point, mass capital M is to negotiate a curve. And as it negotiates a curve, you can show normal will be then in which direction on it. Normal will no more be vertical on it. Normal will be somewhat like this on it. In turn, what capital M will do is, will apply force on small m in this direction. If it applies force on small m in this direction, then there will be a component of this force in the horizontal direction, which I am to draw for you, is this. We don't have any qualms with vertical component. Vertical component will be balanced by earth or floor. Horizontal, what is that to do? Isn't obvious. It is to make small m move to our right. So small m will start moving to our right. Capital M moving, small m also started moving. They will move. They will move. Up to what point they are to move together, that'll depend on what impetus we have provided. Yeah.
So Udbhav and Arnav are asking to be let in.
Okay. So up to what point they are to, that we will see. But what it appears to us as per the language used by the author is, it is not to leave. it will leave only post touching the pinnacle. If this is the pinnacle, is what I'm marking it to be. That's the pinnacle to us. This one. So it will leave post touching the pinnacle. Before of that, contact, so far as the language of question is concerned, which comes from Ayurveda, is ascertaining there being no lost on. So no lost on the contact till this point. It is to negotiate entire of the track. So capital M we are secured on will come up to the top. Till top, it is not to lose contact. It comes over here. They are moving together. This is capital M. This is small m. They are moving together. After of this point, what will happen? Capital M will leave track. And when capital M is leaving track, mind you, they are both moving in the horizontal direction with same component of velocity. Why? Because they are touching each other. So this is the long and short of question. What the author did ask, what they asked is on the maximum height achieved by capital M. What will be maximum height achieved by capital M being asked? We'll further this ask of Eurodove, and I'll ask you later, where will this mass capital M eventuate? That means, where will the mass capital M land? So we'll be adding to Eurodove question for the organic question to what height it will rise. That's being asked. So far as the givens are concerned, we know V naught, capital M, small m, and also this height. This height is also in our know. And this height is, let's say, capital H. We have to find what is the maximum height reached by capital M mass. Maximum height. So this being the question, an application of what we studied the other day. So I need to ask the ones who were there the other day present. What say class? 4 of you were present. I presume all 4 are present today as well, right?
Yes, sir.
Okay. So can we say in this system, the system which comprises of capital M and small m, can we say for this system which comprises of capital M and small m, there is no force external in horizontal direction. There is no force external in x direction. Can we say that? Yes or no?
Ignoring the
Ignoring
initial
what?
impulse, yes.
Yes, of course, we are not taking the initial into
The initial
consideration.
impulse.
Initial, we are not taking into consideration. We are taking into consideration motion being set. Okay, the system being set. After get go. Getting it here?
Yes, sir.
Okay. So you approve of there being no component of force in horizontal direction, right there?
Yes, sir.
Yes, sir.
Okay, let me write that for you. So force external, as we did the other day, force external in x direction is 0. We know up to how far we can go from here. We can go up to what level known to the class, which is B Cm x is equal to a constant, right? Yeah.
Yes, sir.
Okay. Then a pausation. We take a pause and check for what was the state earlier. We got to know earlier, initially, what was velocity of center of mass. It was Zero to us. It was not moving or moving. That depends on from where you are initiating your process, isn't it? Yeah. It depends on from where you are initiating the process. What can we say for sure? Initial momentum, whatever it is, will remain conserved. I'm not going beyond this. Let's say I don't know why I should not take thrust. It was given to me that there was an impulse, there was an impetus given to the body. Okay, that. So I'm not going beyond it, but VCM X we know will be a constant for sure. And if VCM X is a constant, then can we say that momentum in X direction will remain conserved? Why? Because there is no force external in X direction. We
Sir,
get VCM as constant. So momentum in X direction will remain conserved. This is one statement that
Sir.
I'm making. Yes, dear.
When we push it, the small block is given impulse, right?
Yeah, small block is given impulse, and we are referring to a situation when we are going beyond that event. Okay, we are not referring to before of the event, beyond that event.
So the thing which it's sliding on will also move forward with an acceleration, right?
Yeah. It will move forward. It will move forward because there is a force, and with this force, bodies are to move with acceleration. There is no
Yeah.
two way about it.
So
Yeah.
if from non-inertial frame, pseudo force will be there, right?
I am referring to which frame? That should be first clear to us. I am on Earth. I'm referring to a frame which is inertial. And I am conserving momentum in X direction. In order to conserve momentum in X direction, I'll have to ensure that there is no force external in X direction, right?
Yes.
So if there is no force external on what? You need to ask me what? Force external on what? Force external on system.
Small. Oh, okay.
No, 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 no. Please be very careful on the statement made over here. Don't inflict doubts. I said what I have taken system to be. I have taken system to be a combination of small m and capital M, okay? If you will take only small m, or if you will take only capital M, then there are external forces on both in positive X direction or in X direction, okay?
Yes, sir. I
But if
understood
you
you.
take system, then there is no force external on the system in X direction. Got it?
Normal cancels out. Yeah.
Because normal becomes an internal. It's not about cancelling out,
Yeah.
it becomes internal.
Yeah.
So there is no force external in X direction. Correct? Correct?
Yes.
On what? On what?
System.
System, which comprises of
Small block and wedge or whatever. Yeah.
small block M. Only M?
No, both the masses.
Yes. Both the masses, small m and capital M. Correct?
Yeah.
If that's the case, can I stretch and push in the envelope stating that momentum in X direction will remain conserved?
Yes.
Okay. So what is momentum initial of the system? Now initial of the system is small m into 0 plus capital M into V0. There's a momentum. As I'm conserving only along X direction, I'll keep it as what it is. In X direction, V0, bereft of bar. So this is the momentum initial in X direction. I don't know what will be velocity in the or component of velocity in the upward direction. Therefore, I mark Vy for it. We certainly know that there is no possibility of it being other than Vx. Be it small m, capital M, If a small m is moving with Vx in x direction, capital M is to follow. If capital M taken first and said to be moving with Vx in x direction, a small m is to comply to it. Yes or no?
Yes, sir.
Yes, sir.
Yeah, it is must. Else what will happen, known to you, they will not be in contact. Right, class?
Yes, sir.
Okay. What do we write over here for x direction collectively? Capital M plus small m into what do we have here? Is Vx.
Vx.
Right. So this gets us one equation which is based on conservation of linear momentum in x direction, x being to our right. The other equation which we have, which I like to circle on, I ask you to go on and let me know, are you affirmative or in negation to my ideation? And that being, we can conserve mechanical energy for the system. Do you agree?
Yes, sir. There is no non-conservative force except for the initial impulse. So,
And if I say I want to conserve energy for capital M, what is your take? Only capital M.
sir, again, we could do that. That's okay.
No, sir. It would
No,
be
normal is
normal
acting.
force. For the whole system, we can conserve it. Otherwise,
So reflect on it. If is only small m or only capital M, are we to exercise caution? Okay, class? Can we even then say that conservation of mechanical energy will follow? Think about it. Yes. As system concern is what my question is pinned on. Certainly we can conserve mechanical energy, right, class?
yes, sir.
No sliver of doubt on that front. Going ahead with it, half m v0 square. We can take any reference for potential energy. So I'm marking the reference so that there is zero potential energy associated with the masses. If you want to mark it as zero, so that we don't have much to bother, we can take this level as zero potential energy. Yes, center of mass will lie somewhere. See, these are the rotae. Center of mass of this system will lie somewhere. So you ought to write mgh. But mgh here and later also mgh, there is no point writing it down and striking from both the ends of equality. I choose not to write mgh for track. Mgh for track will not change. So this is kinetic energy initial of capital M, potential energy initial 0, kinetic energy of track 0, potential energy, we may say mgh prime, where h prime is center of mass position from 0 potential. Then we move to what we want to, this state which is being shown on board. What is kinetic energy to be marked of capital M? Half m Vx square plus Vy square. This is what we have for kinetic energy of capital M. Then we move on to potential energy of capital M, which from here is mg capital H. Kinetic energy of small m, the track, half m Vx square. Potential energy, whatever was initial, will be final. Initial not written, so is not final. This is our equation pertaining to conservation of mechanical energy for a given system. Good enough. The question remains unsolved. I want some spunk from any one of you on the answer now. Maximum height, come on.
So we can find Vy and then it's a projectile. So
Okay, okay. Please go ahead. Reveal more. Reveal more. Yes, yes. You're on right
Okay, we
side.
said Vy is 0 at the moment of max height.
No, I didn't say Vy will be maximum when it reaches, then Vy will be 0. You're right. So if we
Yes,
take only y direction motion into consideration and use the kinematical equation which reads Vy is equal to Vy naught square, correct? Plus of twice ay, y minus y naught. Okay, so Vy square for me will be 0 at the highest position. Vy naught for me is what I have written over here as Vy. Ay is minus g for me. And y minus y naught will be the additional height attained when it stops, correct? Is it good? Just y direction, focus on y direction. Actually, it will move in a projectile. You're absolutely an object on it. But what I'm referring to is only y direction motion. What do we get from here? Final 0 is equal to Vy square minus of 2g h prime. So h prime is how much from here, class? Vy square divided by twice of g. Or in other words, you have a replacement for Vy square here. Half m, this is Vx square, good enough. And we have a replacement for Vy square, which is what to read, class? 2g h prime. Do check. Plus mgh plus half m Vx square. Received well? Am I being received well, class?
Yes, sir.
And you know what do we get from here? Do check. Here we get it as half capital M and small m from there. Vx square common plus m g and what else? H prime plus h. Idea? Yes or no? And h prime plus h is the maximum height. H prime plus h is the maximum height. Are they to sum get us maximum or not, class?
Yes, sir.
Okay, and Vx is known from equation number 1, so this question stands solved. So far as what being asked in Euro is concerned, we are through it. Do check a certain culmination on what being asked in the book. We'll add to it, as I've told you, and that will be the process for every question that we will be solving. Something or the other is to be added from our end to the book. That's the algorithm, pedagogy that we follow. Well received, class? Anything to ask? All right, shall we move on?
Yes, sir.
Okay, so block leaves the track. Block leaves the track, it flies off the track, it is moving in a parabolic path You did say whatever. I am into accepting each and every word of it. I further need to where will the block land?
So exactly where it left on the track, the apex of the track.
Why say so?
Because, sir, it's a projectile with x velocity vx, and the track is also moving with vx. So the relative velocity along the x-axis is 0. So when we look from the track, it's just
Kudos,
going up and down.
kudos, very good. Absolutely correct. Good. So land exactly at the same point, not vis-a-vis Earth, vis-a-vis track, correct? Correct?
Yes, sir.
Because track will move forward with Vx, so will the mass. Mass will move up and fall at the same place. Wherever it falls, it will find track over there, right?
Yes, sir.
Relative velocity or relative component of velocity in x direction is 0. Good. Okay. Shall we further? Who was
Yes,
this?
sir.
Who did answer?
Sir, Ahan.
Aham.
Ahan, sir.
Okay. Did the class get it? Ah, got it. Ahan, no, sorry. Did the class get it? That's the reason I thought there is no aham in my class. Okay, Ahan. So is it okay? Class, did you get it?
Yes, sir.
Okay, good. Divyansh, where are you? Devansh? Devansh, are you there?
Yes, sir.
Yes, Devansh, you didn't interact?
Oh, sir, I said yes, I understood.
Okay, okay, no. Did you get that? I didn't get the answer from you.
Yes, sir, yes, sir. You were speaking, so I
Someone has
said
told us? Okay. It's not that someone has told you thunder, right?
no, sir.
Okay, good enough. Fine, class. We move on to the other questions. There are a plethora of questions to be taken. I would wish that you get done with the package question to the earliest so that we can add to questions from different book. You are getting time, class. Make best of it. These moments are not to return to you. So please don't repent if lost. Make the best out of it. Okay, let's move on. Write down. The part which I'm next to take class. Okay, I'll take one more question and then I'll move to that part. Rocket propulsion part which is in advanced, not in mains. But I'll take that part later. Let me take one more question at least on this. For those who have not, excuse me. For those who have not affiliated themselves to my previous class, I am taking this pain of additionally solving this question. Else who have moved easily to the next topic. This is a smooth surface. There is mu between the two surfaces. Capital M is long enough, so there is a remote possibility of a small m toppling over capital M, the long track capital M. V0 is the initial speed which small m is being set with. You are to pick on the 4 plots, one of the 4 plots which I am to draw for the variation of momentum of these bodies with time. Variation of momentum of these bodies with time.
Sir, of each individual body or the system as a whole?
Come again?
Sir, of each individual body or the system as a whole?
Individual.
Okay.
Individual. We have to draw for variation of momentum of small m and capital M individually, but on one plot with time. What happened to momentum? May I ask in piecemeal over a question, which is, what is the class to opine on eventuality? What will happen eventually? Small m initially in motion, capital M at rest.
So
There is enough friction. Yeah. Carry on.
eventually, due to friction, small m would stop with respect to capital M,
Okay.
and capital M would move on the smooth surface with the same momentum that small m initially had.
A little
No, sir,
there.
you can't say that.
A little there. Same momentum with which capital M was moving initially. Small m, right? That is what he said.
Yes, sir.
Yes, sir.
Tell me one thing. If small m, capital M is to move with same momentum with which small m was moving
No,
initially.
no, sir. It wouldn't because small m is also moving with respect to Earth.
Yes. Yes. Would you reflect or reevaluate your answer?
So the momentum of the system would be conserved because friction is an internal force.
You're right. You're right over there. Friction internal force of system momentum in x direction will remain conserved. No two way about it. Correct. So what will happen? Can we say that? Finally, as you were, I'm just to reinforce it. Finally, they will move with same speed, right?
Yes.
Small m cannot move over capital M. It will eventuate with they moving as a unit. Can we say that?
Yes, sir.
Yes, sir.
So final speed will be same, no doubt about it. Final speed is ought to be same. Conservation of momentum for the system reads mv0 is equal to capital M plus small m into V common. Okay, good enough. V common. Okay, class. I'm just marking 2 questions so that I don't lose on them. These questions also I would wish solved. So this is the first one and second one. In case I miss on them, remind me. So this is mv0, m plus m, v common, final. V final you can write if you deem so. So v now is equal to how much? mv0 divided by capital M plus small m. This is the v with which bodies are moving. Okay. Tell me what is happening to them individually. Let me isolate them. Let me take the bodies in isolation. What is happening to small m? On a small m, force of friction is acting, right? Which is changing its momentum. Can we say that?
Yes,
Yes,
sir.
sir.
Okay. So is on capital M. And capital M also is acting force of friction, which is appreciating its momentum, right? Small m, friction is to depreciate, and capital M, it is to appreciate, right? Yeah.
Yes.
Okay. Now the question is, what kind of variation will it be? Will it be a linear variation, a curvilinear variation? What is the variation? How is the velocity changing? If I get how velocity is to change, I will be able to plot for momentum. Correct? Correct.
Yes, sir.
And for change in velocity, what I require is acceleration. Correct?
Yes, sir.
Yes, sir.
So what is the force which is to provide acceleration known to us? That force is force of friction.
Friction.
Correct? Correct?
Yes, sir. Yes, sir.
So if that force is force of friction, question boils down to what is force of friction? The force of friction, till the time they are moving, till the time they come to the state of moving together, they are in the process of rubbing each other. Which force of friction will act between them is an obvious, right?
Kinetic friction.
Kinetic friction, which will be how much for us to read? Mu into normal, right?
Yes, sir.
So mu into small mg, right?
Yes, sir.
Yes, sir.
Okay. So mu into small mg is a term which is constant. Can we say that it being a constant, acceleration is constant, right?
Yes, sir.
And if acceleration is constant, then component of velocity in x direction will be linear, correct?
Yes, sir.
Yes, sir.
It will be a linear function, yes or no, class?
Yes, sir.
So what we get to see from here is variation of momentum will be shown by a straight line, correct?
Yes, sir.
Yes,
Are
sir.
you clear on this front or not, class? Acceleration, let me write it down for you. Acceleration in x direction. What is that to read? That is to read mu k mg by m, which will get us mu kg. As it is a constant, kinematical equations will apply. We have Vx is equal to Vx naught plus Ax into T from our pages of kinematics. We write over here Vx at any time t is equal to V naught minus of mu k g into t. This is for small m. For capital M, what do we have? We have Vx is equal to 0 plus mu k gt. They being linear function multiplied with respective masses will get us variation with time, right, class? Right?
Yes, sir.
Yes, sir.
So what kind of a plot we are to set? What kind of a plot we are to set? One will see a drop. It drops. Why negative? Obviously, you know, slope is negative. So one will see a drop, then will become constant. Right, class?
Yes, sir.
Yes, sir.
And the other will see a rise. Correct? The other will see a rise. Let me draw more specific to you. So one is to see a drop. This is the drop seen by one. It goes this way then. The other starts from 0. It sees a rise, goes this way, and then constant. Do check, confirm. Good enough? Is it good, class?
Sir, I have a doubt.
Yeah.
So initially, it's moving, block M is moving with V naught to the right, and then later on it will be moving to the left, right, when it achieves the final.
No, how will it move to the left?
Because Its velocity is decreasing, and
With respect to capital M.
Decreasing, but it doesn't mean
It's not getting
direction
negative.
change. Negative, how will you get? It
No,
is decreasing. It will come up to the level wherein
With res-
both are to move forward, right?
with respect to capital M.
With respect to capital M, it will cease to move,
Okay, yeah.
not backward. It will cease to move. If you are on capital M, it will not move with respect to you, correct? But it will not move backward.
Oh, right. Oh,
How will
I
it
got
move
my
back?
mistake, sir. I got the mistake. I was.
Okay. Okay, this plot is not to scale, as you can see for yourself. Combined should get us the initial value, correct? That is important for us to take a note. Combined should give us the initial value, isn't it, class? This is for capital. This plot is final for which one? For small m. So m into v common. And this is final for which one? For capital M. Capital M into v common. We know that this should be equal to this being v naught, right? So it should be equal to this, correct? They should add up to this. It's not up to scale, but you understand the meaning which I'm trying to prolificate here. Correct, class?
Yes, sir.
Okay, good enough. So this is the plot for us. Sometimes they do ask at what time they will have same speed. So this is the time. This is the time for them to have, this is the time. This time what they are to have? They are to have same speed. Are you getting it, class? Check it, please.
Isn't that one the point of the same momentum?
Very good. I wanted someone to counter. Good. Who was that?
Nivan.
Nivan. Very good, Nivan. Class, which point is what? Don't be mugged. Which point is what? I told you. Please be interactive in my class. Don't take it as duck take to water. Okay, pinch of salt. Very first day I told you. This point when I mark, what is this point indicative of? What is this point indicative of? Yes, class, tell me, what is this point indicative of?
Equal momentum.
This point is indicative of what you are plotting it against, right? Over here, what I have taken speed, correct? And over here, what I have taken time, haven't I? Haven't I?
Yes, sir.
Okay. So when I come to this point, what is to be read same? Tell me. What is to be read same? This is to be read same. What is this?
Momentum.
What is y-axis? Is it
Speed.
momentum?
Speed.
So what is to be read same? What is y-axis? Is it momentum or speed? Come on, class. What happened?
Speed.
So what is to be read same?
Speed.
Speed. Momentum would have been same provided their masses were even, correct?
Yes, sir.
So if I'm to ask you tutelar for T1, you will say this is eponymous to what being same? Speed being same, okay? What being same, class?
Speed.
Speed being same, okay? Okay.
Yes.
Yes, sir.
Now, here yes, there yes, every time, whatever you ask, if you're asking with slight high pitch, then you will get a yes, an affirmation. Now tell me, class, if speed is same now, then what happened finally? If speed is same now, then what happened finally? Yes, dear. Now what happened? Cat caught tongue. Tell me. Please be very careful.
So if it was a speed
Please
time graph, it
be
would look
very
different.
careful. If you take speed on your y-axis, then this plot
Graph
will
would
be
change.
different. Okay? If you take speed on y-axis, then this plot will be not the one what I drew or what I did get you. Getting it? I got you what against what? I got you momentum. So this was what to me to begin with? This was momentum, okay?
Yes, sir.
So if this is momentum, only then you will get up and down. And this will be what to us then? This will be mv naught. Didn't I tell you that it should match? Yes or no?
Yes, sir.
Now tell me what is T prime or T1 to get me for this plot, momentum one. What is that to get me? What will be same over there at T prime or T1?
Equal momentum.
Equal momentum. Got it? Equal momentum. And when will the speed be same? When will the speed be same? At T2, correct?
Yes, sir.
So which is attained first? Same momentum, same speed for this plot.
Same momentum.
Yes, please write it down categorically, everything now. No confusion. We did split hair. We did cut it with certain precision. See that it's clear to one and all. Done? Done, class?
Yes, sir.
Okay.
Yes.
Okay, right next. Two masses M1 and M2. Two masses M1 and M2 connected by a spring of spring constant K. Connected by a spring of spring constant K. Are kept on smooth horizontal surface. Are kept on smooth horizontal surface. One of the two masses is pushed to the right with velocity v0. With velocity v0. Find maximum amount of elastic potential energy. Find maximum amount of elastic potential energy stored in the spring. Find maximum amount of elastic potential energy stored in the spring. What will be the maximum amount of elastic potential energy which will be stored in the spring being asked? So there are three questions which I have marked. I take one of the three, second one first. Given to us, there are two blocks. One is this to us. Let me mark it M1. Spring constant K. It is given a thrust to the right with V0. And you've been asked in this state, what will be the maximum kinetic energy stored in the spring? Let me pull in the concept that we have studied class, which says K is equal to KCM plus of half capital M VCM square. Kinetic energy with respect to any system is equal to kinetic energy with respect to center of mass plus of, which is to add to it kinetic energy of fictitious particle of mass capital M being the total mass of system, positioned at position at center of mass and moving with VCM. Position at center of mass of the system and moving with velocity of center of mass. That is what we have for this equation. We are also aware of for two body system or two particle system, kinetic energy shape to half mu mod of V1 mod of V2 . This is the kinetic energy equation. So you want, what is the objective? There are many ways of solving this question. You can also think about it, Egon, and you will get to know that this body will see maximum elongation or deformation, this spring, when both the masses are moving with same speed. Do you agree? Do you agree? Spring will see maximum deformation when both the masses are moving with same speed. Do you agree or not? If you don't agree, sit on one mass and see. Till the time there is a relative velocity, it will extend, right? If you're seated on M1 and you still see M2 to be moving, then the spring is in an elongated state. It is elongating further, correct?
Yes, sir. Contract.
When will the elongation cease? When you move with M2, right?
Yes, sir.
Okay. The other way of looking at it is through the equation that I have written. Now here, kinetic energy of the center of mass will be 0 when V1 is equal to V2, correct? So kinetic energy as seen from center of mass, 0. That is what we can do. See, I have to maximize potential energy of system. Say yes or no, elastic potential, yes or no?
Yes, sir.
So if I have to maximize elastic potential energy of system, then it goes without saying, we'll have to minimize kinetic energy. Agreed? Agreed?
Yes, sir.
Yes.
Because why I say so as energy of the system will remain conserved. Are you in confidence with it or not?
Yes, sir.
So we need to minimize kinetic energy. We cannot touch half mVCM square. That will remain as neither capital M nor VCM change. So they will remain what we can best do is we can reduce kinetic energy as observed from center of mass to a zero. And that we can do provided V1 is equal to V2. That means masses are moving with same speed, right class?
Yes, sir.
So what do we get to see then? What is kinetic energy of system? Half BCM square. And when we will get its minimum, it is this moment when V1 is equal to V2. And if V1 is equal to V2, we go ahead with conservation of linear momentum. What do we write? Initial momentum as is M2 V0. And what we can write the final as is M1 plus M2 into either V1 or V2, right? Okay, correct class? Say yes or no? Or B?
Yes,
Which
sir.
one?
Yes, sir.
Either. We get from here, what is V or final value? V is how much? Is M2 V0 divided by M1 plus M2. This is V for me. Now you know what to do. Nothing much left, isn't it? Initial kinetic energy known to you. Elastic potential energy initially 0. Finally known to you half small m plus cap or m1 m2 everything, right? So m1 m1. Why did m2? Oh, m2 m2 m1 plus m2 v square plus maximum elastic potential energy. Do check class. Agreed?
Yes, sir.
Please write few words. It'll get evaporated. So fix it by writing why did we first. By logic stated V1 should be equal to V2, which was furthered with mathematical substantiation vis-a-vis kinetic energy when viewed from center of mass frame. Check it out, class. Take your time. These are important concepts. Need not rush through. You see to it. They are amply clear to you. Okay? Am I good? Good class?
Yes.
Yes, sir.
Okay. The other question right now. Two spheres, two identical spheres collide as shown in the figure. Two identical spheres collide as shown in the figure. Find the loss in kinetic energy when the system is in maximum deformation state. Find the loss in kinetic energy when the system is in maximum deformation state. The other question also, if you deem, please do write. A body of mass 3m, a body of mass 3m explodes in 3 particles, explodes in 3 particles having velocities v1, v2, v3, having velocities v1, v2, v3, such that kinetic energy of the system increases eta times, such that kinetic energy of the system increases eta times. Eta is a symbolic representation, eta times. Find maximum speed with which any of the 3 particles can move.
Sir, I have a doubt.
Say?
So not related to this topic, but let's say there is an object which is being held by another object moving with a constant acceleration. And if the object which is being held is let go, then only the instantaneous velocity of the object which holds it will be imparted, right? Not acceleration.
Velocity will be important, not the acceleration. Acceleration will depend on the forces acting on the body.
Okay.
Yeah. So in this question,
Its velocity will get added, right?
okay, beta?
Its velocity will get added, right? The hand's velocity, like the thing
No,
will.
that's if the object is moving, is also moving with
Yeah, yeah. Otherwise, it just get the velocity of the hand.
at the instant, yeah.
Now, what I was to ask is, given to you that the body explodes, if I'm to refer on reverse logic, taking last question first, there is a body and that body explodes. It explodes into 3 fragments, let's say masses m1, m2, m3, velocities v1, v2, v3. Okay. Now, we have our liberties on maximizing speed of one of the particles. That liberty we can exercise. We can maximize. Whatever required for it, you may assume it to be given. So given favorable condition, what can be maximum speed attained by one of the 3 particles? That is the question. And question is being stated that it explodes. Now, if any body will explode, it will explode out of some reaction or energy addition which will appear in the form of kinetic energy. If explosion is taking place, it's energy, and that energy, because of which explodes, will appear in the form of kinetic energy. We know that. So what will happen to kinetic energy of the system? Author says that the kinetic energy of the system, owing to explosion, owing to this event explosion, increases eta times. Eta can be anything. So it increases eta time. Kinetic energy increases. How will you work it out? One of a question, intriguing question from Irodo. Very good question. Very good question.
So the force inside the mass which causes it to explode is an internal force, right?
Yeah, correct. It is internal.
So momentum is conserved.
Yeah, momentum will remain conserved. Momentum should remain conserved. It's internal force, right? There's no force external, right? Isn't it?
Yes, sir.
Right. So this is the scenario with us. Let us see how we'll go about it. Multiple way of solving it, but I am in center of mass frame, so I'll try to deploy center of mass concept. Center of mass frame concept. I write equation for you. K is equal to K prime or KCM plus of half M VCM square. Right, class? This is kinetic energy equation. Good enough. Body initially of what mass? Thrice m. So this is a sphere. Let me draw for a sphere. Thrice m mass moving with V0. Kinetic energy initial, if we mark it as Ki, Ki is the symbol for initial kinetic energy. Then what will be the kinetic energy post explosion? Eta Ki. This is the kinetic energy post explosion. Okay. Now, what is kinetic energy is an obvious. We know half 3m V0 squared initial kinetic energy. If you wish, right, you can write that down. Half 3m V0 squared. As I want to pitch in K prime, I've told you that I'll be pitching in K prime. So how can we pitch in K prime? What we can say is, let us introduce few terms, which is speed or velocity with respect to center of mass. I'm writing few terms over here. V1 prime, V2 prime, V3 prime. These are as read from center of mass frame. What is ringing? As read from which frame, class? Center of mass frame. Is it okay?
Yes, sir.
So can you tell me about relation between the three of what I have written? Can I write M1 V1 prime plus M2 V2 prime plus M3 V3 prime is equal to 0? Any problem? After explosion, these are the velocities of the particle. And where are we observing from? Center of mass. We are at center of mass. See, class, before you say yes or no, think about it. Don't just say yes because I've asked you a question. Okay? Think. Think hard. Be a hardball bargain. Okay, class? Any confusion? Reflect on it, only then be affirmative to my ask. Don't blanket statements say, yeah. What I'm asking is m1 v1 prime plus m2 v2 prime plus m3 v3 prime. If there is any confusion, divided by m1 plus m2 plus m3, and then you will be sure of that the quantity which lies to the left of equality is nothing but velocity of center of mass, correct?
Yes, sir. From the center of mass frame.
Yes. So you are at the center of mass. I have told you that v1 prime, v2 prime, v3 prime, they are all observed from where? Center of mass. So you are at the center of mass and you are trying to observe velocity of center of mass. What will you be reading?
Zero.
0. And this also comes from what we ideated the other day, summation of mi vi prime is equal to 0, correct? Correct?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So I rewrite my equation. If masses are same, then all the more good to us. What we can then write is v1 prime plus v2 prime plus v3 prime is equal to what to us? Is equal to 0 to us. All the more good. Provided masses are same. Getting it, class? Getting it?
Yes.
Yes, sir.
I want to maximize velocity of one of the particles. So what I do, I keep it to the left of equality and take the rest to the right of equality. V2 prime plus V3 prime. Now take a pause over here and read this equation. What is this equation to say? If you want to maximize V1 prime, then resultant of V2 prime and V3 prime, let's say resultant is in which direction? Let me show you. This is done. This is done. The resultant is in this direction, let's say. So if the resultant in this direction, then V1 should be in which direction, class? As per the equation, this direction, correct?
Yes, sir.
Tell me yes or no? That is what we are getting? Correct?
Yes. Yes, sir.
If we are to maximize, then the angle between V1 prime and V3 prime should be 0. Magnitude maximization, correct? Magnitude maximization, say me yes or no? This is getting you relation for vector. Are you getting it? This is getting you vector relation. But my aim is to maximize speed. So if speed is to be maximized, then angle between V2 prime, V3 prime should be 0. Agreed or not?
Yes, sir.
Then what we are to say? We are to say V1 prime should be equal to V2 prime plus V3 prime. See, class, it takes a lot of understanding in moving from equation 1 to equation 2. They are under a rider, and the rider being, I want to maximize speed of one of the particles, and the particle chosen by me is particle marked 1, correct? Correct?
Yes, sir.
Okay, okay, good enough. Good enough. Fair. We already know what is the kinetic energy equation. Kinetic energy initial and kinetic energy post explosion. What is kinetic energy initial? Ki. What is kinetic energy post explosion? Nki. Ki is written over here. I'm reading everything post explosion. What I'm doing? I'm reading everything post explosion. That means I'm reading kinetic energy. I will apply this kinetic energy equation post explosion. Clear, class? So what is kinetic energy post explosion? This equation I'm applying. And I'm applying for what condition? Post-explosion. What is kinetic energy post-explosion? Eta time kinetic energy before explosion, which is half 3m V0 square. Okay, good enough. What is kinetic energy as seen from center of mass? Half m V1 prime square plus half m V2 prime square plus half, mass is being same, m V3 prime square, this is the kinetic energy, and half total mass will remain, that is 3m. VCM, as you have said and understood, remains constant, right class? Yes or no?
Yes, sir.
Which is how much? V0, right? Is it? VCM
Yes,
is
sir.
V0, same yes or no?
Yes, sir.
So what do we get? Half 3m into V0 square. Look at this equation, class. Look at this equation. Take the equation. See to it, it has been received well.
So I have a doubt.
Yes, dear.
So how can we assume that all the fragments are of mass m? What if we
No,
can
that's
maximize
given.
it?
Only given. Only given. When is given.
Okay,
Yeah.
sir.
If not, we will not be in a position. Okay. What is ringing here? Why the bell is not ringing? Okay.
Sir, could you explain once again why we took the half 3m V0 square?
Because we are referring to the situation post-explosion, and it being said to us that post-explosion kinetic energy increased by eta to what it was pre-explosion. Pre-explosion, it was half 3m into V0 square, right?
Yeah,
So post-explosion, what will it be? Eta times half 3m
half
into
3m
V0.
V0 square.
Right. That is the one.
Okay, thank you, sir.
Right there. Now what you have to do is a bit of mathematics, though we'll have to muster courage for it. 3m gone, half gone, half gone, m, half, m, half, m. Okay, class? Now, what about V1, V2, V3? We are aware of, we are to maximize V1 prime, so V1 prime remains. What can we write for V2 prime, V3 prime? We have relation. We make good of that relation. V2 prime I keep as it is, V2 prime square, and V3 prime is being changed as V1 prime minus V2 prime whole square plus 3 V0 square. Right, class? Right? Agreed?
Yes, sir.
Yes, sir.
Of course, there are two variables over here, and my interest is pinned on one of the two, it being V1 prime. So someone is to tell me, what shall we do? How shall we go about it? Find V1 prime, I write. V2 prime square, I write. Then I write V1 prime square minus of 2 V1 prime, V2 prime, plus of V2 prime square, and plus of 3 V0 square. So far, so good. Problem remains, which is what to say. I have got two variables, and my interest is with one of the two, it being V1 prime. What to do, class? There should be some idea floated by you. Tell me, what shall I do? Nothing? Take it as a quadratic equation in V2 prime, correct? And then apply. Discriminant should be? Discriminant should be, come on class.
Greater than
Discriminant
equal
should
to
be
0.
greater than?
0.
Greater than equal to 0, right?
Yes, sir. That's what I said.
Yeah, correct. So please do that. Write down. Taking it, which one? Mark this equation, equation number 3. Taking equation 3 as a quadratic equation in V2 prime. And for it to be real, discriminant should be greater than or equal to 0. Discriminant should be greater than or equal to 0. Right, class?
Yes, sir.
Please do the needful. Let me know what are you getting as discriminant. What do we get V1 prime as? Any one of you can come first. V1 prime greater than or equal to, what do we get? Quickly, please. Yes, dear. Quick, please.
So V1 prime should be greater than or equal to 6 V0 square 1 minus eta whole under root.
Okay. Just check your calculation once. If you are reinforcing, we'll go ahead with it. Discriminant should be greater than or equal to 0. Class, work it out.
Yes, it's you can take V0 outside the root, and so V1 prime is greater than or equal to V0 under times root of 6 times 1 minus eta.
Is it 6 or 3?
So I got 6.
Okay. Anyone else? We'll confirm this. Discriminant should be greater than or equal to 0. Is there any confirmation on this?
Yes, sir. I got the same thing.
Was that got the same?
So Nivan.
Okay. And what is that same?
So V1 is equal to V0 into root of 6 into 1 minus eta by 5.
By 5.
Oh, I didn't get the by 5.
Then how come it's the
Okay,
same?
so enough. Okay, sir.
Then how come it's the same? Is it same? Come on, class, work it out. This is twice of, I have got some space. Just a moment here, right? Okay, so twice of V1 prime square plus of twice of V2 prime square minus of twice of V1 prime, V2 prime, and plus of over here, or if I do it this way, then is equal to what we can write, eta, this side 3m V0 square and that side 3m. So 3a I can eta minus 1 I can take as the term in the bracket, and 3 V0 square can be taken out. Right? So we get from here V1 prime square plus V2 prime square minus of V1 prime V2 prime is equal to eta minus 1 3 by 2 V0 square. Right, class? Right? Yes or no?
Yes.
Yes, sir.
Now we have the term which we wanted it to be, V2 prime square minus of V1 prime, V2 prime, and plus of V1 prime square minus of eta minus 1, 3 by 2 V0 square, space crunch, is equal to 0. Right? Right, class?
Yes, sir.
Now apply discriminant. Tell me what are you getting? Did you apply discriminant to this equation?
Yes, sir.
So if you apply discriminant b square minus 4ac, what is discriminant? What is the form? Form remembered or not? Ax square plus bx plus 8.
Yes, sir.
So b square minus 4ac greater than or equal to 0.
0. Yes, sir.
Apply and tell me. B square minus 4ac, what is that to get you? What is b over here? What is 4? What is a? What is c over here? Check. Tell me the equation, please.
So, sir, shouldn't it be 2 V1 prime V2 prime?
What is the equation, dear? That is the reason I wrote the equation for you. What is the equation? Ax square plus bx plus c, right? Is it ax square plus 2bx?
No, sir. In the other equation, the
Mohan, he divided both sides by 3. You see 3 by 2, it is not square on the other side.
oh,
Tell me now, what is it?
it's v1 prime squared. So that's b squared,
Hmm.
and then minus 4 into 1 because 1 is the coefficient of v2 prime, and then c would be v1 prime squared minus
Let me simplify. Let me know what are we
minus
getting v1 prime as. v1 prime greater than or equal to what we are getting. Less than or equal to, I think you'll do it. Less than or equal to. Where are the others, man? What is this? Simply into parroting? Yes? All are there? Check, please. What is happening, class? Only a few of you are answering. v1 prime I want less than or equal to whatever you are getting. Get me the answer, please. Yes, who all are there? Gyanet? Aditi, Advika, who all are there? I want the answers, please.
Sir, I got a greater than equal to relation, sir.
v1 prime greater than or equal to.
Sir, I got
Yeah.
V1 prime is less than equal to V naught times alpha minus 1, where alpha is the change
Alpha is
from.
What is alpha? How I know alpha?
No, like, so you have taken n, I took alpha.
I have taken what?
You took n, right?
Ah, okay.
I took
What we
alpha
got? V
instead of
less than
alpha.
or equal to, what did you get?
V1 prime is less than equal to V naught, then under root of alpha minus 1.
V naught and under root of alpha minus 1.
Yeah,
That means eta minus 1.
yeah.
I'm not getting any 2 over here.
One sec,
Yes,
I'll
sir,
just
there will be a 2.
Sir, I'll
Yes, sir,
recheck
there will be a
once.
2.
Check. I think it. Who got 2?
Yes, sir, Nevan. In my earlier calculations, I think I forgot to change the sign.
Why beta? Why you do that? Anyway, this is the one that you'll be getting. Please check, class. This is the error of question. V naught twice of eta minus 1. Though this is not the final answer. Why? Because this is as seen from center of mass frame, correct? This is as seen from center of mass frame. And if you want it to be maximum, then center of mass should be moving in the same direction as that of this, correct? Yes or no? If you want it to be maximum from Earth, then center of mass should be moving with the same direction, and center of mass is moving with V naught. So our final answer will be how much to read? Final, or the answer which is there vis-a-vis this question will be V naught plus V naught under root of twice eta minus 1. This is the maximum speed that a particle can attain, provided they break into even fragments. They break into even fragments. Check it out, class. One of a kind solution because we are solving it from center of mass frame. I want to make it distinct from what being available. This is the distinction with us. Do check, take your time, let it sink. Also reflect on the process, what we do when there are two variables, how discriminant do come handy. What if I want to differentiate, use integration differentiation instead of discriminant? Ideate on these. You should pause it. Pause it on these terms. Root for a while. Okay? Shall we? Any further?
Yes, sir.
Okay. Let's say, class, there is a rocket. With initial mass or mass at a time, certain time, t. M, velocity of rocket at that time, t. V. After a small interval of time, some change in mass. Now mass is m plus dm. Velocity is v plus dv, all as per calculus. And we know dm will be negative, so this mass of gas will be dm. And it is being ejected with VREL. So these are the situation at t equal to t and t equal to t plus dt. T equal to t and t equal to t plus dt. We know by Newton's second law of motion, dp by dt is equal to what to us? Cos external. So delta p is what to us? Force external into delta t. Change in momentum. Change. Change is always final minus initial. Let's calculate the change. What is final, class, over here? M plus dm v plus dv, we are calculating as seen from Earth, plus minus of dm v relative plus v plus dv. This is of gas with respect to rocket, and this is a rocket with respect to Earth. By the way, those who are purist mathematician will say that this has not come out at a particular time. It has come out as collection, and v relative cannot be taken this. To them, what I have to say, you will not take v relative as this. You can take it as an average. If you'll do average, eventual equation will remain the same. By average, what I mean, what I had to v plus dv. You may argue, no, this gas was ejected with v relative. V relative you want to keep constant, keep, but this cannot be v plus dv, because it will be v plus dv only when it pops at a particular time. I say, okay, it's not v plus dv, then it is v plus dv plus v whole divided by 2. If you want to do over here, v plus dv plus v whole divided by 2, I don't have any objection. Purist mathematician will certainly negate this right. They will go with this right. How will it not change a thing in my case? I'll explain it to you. So it's initial momentum minus final momentum, negative of it, is to get me what? Is to get me force external. I'll write over here. Force external into, I have taken dm everywhere. So instead of delta t, will take dt. Small time. Let's expand. mv plus mdv plus dm into v plus dm into dv minus dm into v relative minus dm into v minus dm into dv is equal to force external into dt. If you were to take this one, what would have changed? You can change. So here I can straight strike the terms. There you will not be able to strike one of the term. One you will be able to, this one. But this one you will not be able to. Nonetheless, there I'll make an argument that dm dv product will be very small. So we can neglect. That will be the argument played there. dm dv by 2 product is very small, so we can neglect. That is what we will be issuing over there as an allowance. Here, that is not to be much done with. Why? The terms are getting cancelled. So there is no need to. If you want to still issue that I'm not considering this is small, I'm not considering this is small, it's okay. Only this will become by 2 if I take this. So dm dv gone in our case. What else? MVV gone here. Okay. Anything else? That is it? Right. Okay. Let's say force external is 0. That means what we are getting? I think one more factor should cancel. Is it cancelling? Anything else? Please do check. MV. No, that's it. Check it out, please. Change in momentum is equal to what to us? Force external. mv, mdv, dmv, dmdv minus dm, dmv, dmdv, all that. 1, 2, 3, 4. 4 got cancelled. Change in the momentum is what to us? As per Newton's second law of motion, change in momentum is equal to force external into dt. That is what we are getting. Any issue, feel free. What we wrote, m plus dm, and we multiplied with v plus dv, then mass we wrote, minus of dm, v relative. V relative is with respect to rocket, we were conserving with respect to Earth. So to that got added v plus dv. Then we wrote change in momentum. Change as to write. I have not written the initial one. So initial, this was the final momentum, and we have to subtract from it initial momentum. So initial momentum subtraction, if we do, then mv will also get cancelled. I'll have to incorporate it over here. This one. Minus initial momentum is equal to force external into dt. So here also you have minus initial momentum is equal to force external into dt, which cancels mv with mv. What do we then get to see? Let us write it down. M dv by dt. I bring dt to this side. Minus v relative. If v relative is constant, v relative you write. Provided v relative is constant. dm by dt is equal to force external. Very important relation. Or the other way of writing is all the more of import to us, which is ma m dv by dt is equal to what to us? Till date we studied that ma is equal to only force external. Now we are getting force external plus v relative being constant, into dm by dt. Check this equation, class. Very important. If we remove the sign, what we are to get, sign of bar is ma equal to force external minus of v relative, as v relative is in the opposite direction, dm by
Sir, why do we not write dv by dt as acceleration?
dv by dt. Where did you get dv by dt?
mdv by dt.
Yeah, dv by dt is acceleration only, right?
Yes, sir. So why do we not write it as acceleration?
We wrote acceleration.
The top.
At the top, we have written acceleration, right?
Okay, yes, sir.
So this is an important relation which we got, class. In case there is no force external acting, and what you get to see from here, you can figure it out. If no force external is acting, we'll be left with m dv by dt is equal to V relative into dm by dt. Please do check the bar and with breadth of bar, we change m dv by dt is equal to minus v relative dm by dt. On. What do we get from here? dm by m is equal to
Sir, dv by minus v relative.
correct. Okay, negative sign. Right, class? dv by vrel, dv by v relative with a negative sign. V relative is constant, we are aware of it. So ln of m, where to where? M naught to m is equal to 1 by v relative, constant. Negative sign up here. V, this side of v, just v. If you inverse it, ln of m naught by m is equal to, what are we going to see from here? V by v relative. So that for the case when force external is 0, and this for the case when we do have force external acting on the system. There's an additional part, advanced, Olympiad. This will come handy. At least one question I'll punch over here. See that the equations are well received, both the equations. Shall I? Shall we punch in a question?
Oh, sir,
Yeah.
Oh, never mind, I got it clear, sir.
Okay, let's take one. So given to you that there is a heap of chain and it comes out from a hole here. Okay, it's coming out from a hole here. Being asked, let's say X part is already down. They're being asked if H is the total length of shackle resting on the arrangement then find the speed with which it will part with table. What speed it will part with table. What speed it will slip off the table. With what speed it will slip off the table. The only change over here, mass per unit length is lambda. It is not massless. Lambda is mass per unit length, which makes it variable mass system. It makes it variable mass system. I'll just help you write the equation. The equation that we got, I'm writing it for you. MA is equal to what we wrote. Force external plus V relative into dm by dt. This is what we wrote. X part is down. So what is mass? Lambda x with A if it is moving, so be it A. What is force external? Lambda xg, gravity. And this part is slightly tricky. V relative, I write over here V relative into dm by dt. We are known to V relative is in which direction? Now, yeah, I won't say unknown to. Let's say V relative is in which direction. So there it was rocket. The person is in rocket will see gas to be getting ejected with V relative. Here you are on chain. So what will you find the heap to be moving with? Is the same speed with which you are moving. You are moving with V, so we will find heap to be moving backward with V. Agreed? Yes or no? Relative means what? You are on the rocket and you find gas to be moving. Here, what is relative? You are on the moving chain and you are finding heap to be moving. Getting it, class?
Yes.
So if you are moving with V, if the chain is moving with V, then it will find, or you will find you being put up on chain, V being put up on chain. We will find heap to be moving backward with V. Yes or no? Yes or no? Yes or no?
Yes, sir.
Okay. So heap is moving backward with V. And that is what we are to write. Nothing much over here. Lambda x dV by dt is equal to lambda xg. V relative is V, let us say, direction taken minus of V, and dm by dt, class. What will be dm by dt? dm by dt. Anyone? What is dm? dm is lambda into small length. So lambda into small length means V into dt, small length. And if I multiply dm with V, what do I get? Oh, dm by dt, not V. I have to find dm by dt. So let me remove this. This is dm for me. Okay, dm done. I have to find dm by dt. So dm by dt. What will it be? Lambda V. So V is already there. And dm by dt is lambda V for me. So what do we get from here? Lambda xg minus lambda v square. Lambda x dv by dt is equal to lambda xg minus lambda v square. This can be also written as v dv by dx, you know very well. So lambda x v into dv by dx is equal to lambda xg minus lambda v square. Lambda we can get free of. Xv dv is equal to x dx g minus v square dx. Check it out, class. Which is what to get us? V square dx plus xv dv is equal to gx dx. Now, technically speaking, this is something which you will learn in days to come, and that is differential equation. Then you'll get to know how to solve for these differential equation easily. For now, you're not aware of differential equation. So what can I ideate is we have to so fix it that I get terms. I get terms which I can decode easily. So a bit of manipulation over here. If you want to leave over here, say I don't have any problem leaving over here. When you get to know how to juxtapose differential equation with this mathematical, it's a particular mathematical question, mathematics question with mathematical application, then you'll be able to identify what I'm trying to do. So you can take what I'm trying to do as duck takes to water and then see to it if you are getting or not this equation. Just check over here what all we have written till now. If there is any confusion on what written till now, let me know about it. Now, why am I ideating it? See, this is VDV, and we have learned about this can be written as differential of V square by 2, right, class? Yes or no? VDV, getting it? VDV can be written as differential of V square by 2. Yes or no? Tell me, dear.
Oh, yes, sir. We've done it before, yeah.
Yeah. So if I can get differential of V square by 2 and over here V square, I would like to get over here something which gets me differential of x square. If I write x over here, so I get x dx. X dx will get me differential of x square. So my aim should be to get x over here. My aim is to get x over here. So what can I do? I can multiply through and through with x. See, how will it benefit me? V square x dx plus x square v dv is equal to g x, 1x and 1x, x square dx. Now see, what is the benefit of doing this? This I keep v square and this I can write as d x square by 2. Then this I keep as x square and this I can write as d v square by 2. And to the right what we have? G x square dx. 2 if we take to that side, we get this as differential of x square v square is equal to twice of g x square dx. Do check class. Do check this one, this one, this one. V square out differential of x square. You have taken that, sir. Then x square out differential of v square. Getting it? Collectively we can write this. Are you connecting, class?
Yes, sir.
If you've connected, then you know what to do next. Integration. Integration means x square v square is equal to twice g x cube by 3. X square and x cube gone. We get from here v square is equal to how much? 2g x by 3, or v is equal to under root of 2gx upon 3. Whatever is x, you can place over there. If they are given x is equal to h, it can be placed over there. We get an answer. Check out the methodology for now. What we did. Tell me, when collision take place, it's a question. Firstly, collision doesn't mean that two bodies are to hit each other. Collision means, remember, change in momentum. Alpha particle going this way got deflected. That also will be counted as collision. So collision means what? Simply change in momentum. Now, when collision take place, I am talking of regular collision, so I will take physical touch. Collision is taking place. One body was moving with, your friend was moving with 5 meters per second, you were moving with 10 meters per second, and the two of you were moving along a line, they you two collide. So what will you try to do then? You are moving with 10, your friend was moving with 5. Both of you are colliding. We are in the state of collision. We are over here analyzing collision, what exactly it does. Will you not press upon your friend? Because you are moving with 10, your friend is moving with 5. So what will you do? Will you not press upon your friend? Yes or no? Yes or no, class?
Yes, sir.
Okay, you'll press upon your friend. So you'll try to increase speed of your friend, right? Yes, sir? Agreed?
Yes, sir.
Okay. And what will your friend do in turns? Will try to decrease your speed, correct? Correct?
Yes, yes, sir.
So till the time this process is on, your body and your friend's body will keep on deforming, yes or no? Think about it, class. This process is on. What are you doing? You are trying to press upon your friend, and your friend is returning that press. Your friend is reciprocating it. So what is happening to the system? When I talk of system, I am thinking of your body and your friend's body. Are they not getting deformed? Agreed or not? Agreed?
Yes, sir.
So till what time they will get deformed? Till what time deformation will take place? Will there be any mutual agreement some point in time between you and your friend? Or will this happen ad nauseum till cows come home, that we will be pressing upon each other? Is it so? Tell me.
No, so the deformation will stop.
Yeah, so till the time the two of you are in unison, till the time there is mutual consensus, okay, we'll be moving with this speed, deformation will continue, right? Right?
Yes, sir.
So deformation takes place till the time both of you start moving with same speed. Can I say so?
Yes, sir.
Can I say so, class? Yes or no? There will be a time when both of you are moving with same speed or not. Think about it. You are moving with this, your friend with this. What do? You push upon your friend. Your speed is decreasing, your friend is increasing. Your friend. So there will be an even equipoise. We will strike a balance. Somewhere we'll be striking a balance. Agreed? Agreed?
Yes, sir.
Yes, sir.
So at that time we will be touching each other but will not be pressing upon each other. Agreement? We'll be moving together. We'll be moving with same speed but will not be pressing upon each other. Agreement or not?
Yes, sir.
Okay. Can we say that is the time of maximum deformation?
Yes, sir.
So what happens when you are colliding? Then what is happening to the kinetic energy of system? Think about it. Deformation means what? You are trying to deform this body, let's say. If you are trying to deform a bottle, you are trying to crush a bottle, that means you are doing work on that bottle, right? Right?
Yes, sir.
Yes,
And
sir.
that work will be stored in the bottle in the form of deformation energy or potential energy, correct?
Yes, sir.
Yes, sir.
If material of bottle is elastic in nature, then what will happen? It will try to regain its shape and size. Agreed?
Yes, sir.
Yes, sir.
Thereby will release this potential energy and get this potential energy converted back to kinetic energy. Getting it?
Yes, sir.
So what happened during the course? Can we say that during the course kinetic energy remained constant? Can we say that? During the course of collision, can we say kinetic energy remained constant? Can we? Yes or no? Archie Verma asked a question. During elastic collision, kinetic energy remains constant or kinetic energy remains conserved? What will you say? What will you say? Conserve or constant? Say, class, what happens? You are moving with kinetic energy, your friend was also moving with kinetic energy. Then you started, both of you started pressing upon each other. So what is happening to the system? System is getting deformed. By deformation, what we mean? By deformation, we mean system is gaining on potential energy, deformation energy, at the expense of kinetic energy. So kinetic energy is decreasing and potential energy of the system is increasing. Correct, class?
Yes, sir.
And will continue till the time both the bodies started moving in the same direction, normal direction. You'll come to know the other two collision, the other collision oblique. So we say when both the bodies started moving in the normal direction or in the head-on direction with same speed, at that time deformation will cease. Now, if the material are elastic in nature, then they will try to regain their shape. Therefore, the bodies will now push each other, doing work on each other, and that push will reflect in the form of kinetic energy. Bodies will regain, system will regain its kinetic energy, correct?
Yes, sir.
So during the course of this event, did the kinetic energy remain constant? What will you say of the system?
No, no, sir.
No, sir.
Please remember. Kinetic energy didn't remain constant. Did kinetic energy remain conserved? Yes or no? Conserve means before event, after event. If the bodies are able to regain their original shape and size, will the kinetic energy remain conserved? Yes or no?
Yes, sir.
Yes, sir.
So I think you know the difference between conserve and constant. We cannot say kinetic energy will remain constant. Yes, we can say kinetic energy will remain conserved. Also, you got to know when will the body attain maximum deformation. And whenever the body is to attain maximum deformation, at that time, what will be least, class? Which energy will be least?
Kinetic energy.
Kinetic energy of system. And which energy of system will be maximum?
Potential.
Deformation potential energy.
potential energy. And that is what we are to read in the question number 3. Question number 3 says, write down. Two spheres of same mass, collide. Find the loss in kinetic energy. Find the loss in kinetic energy when system is in its maximum deformation state. When system is in its maximum deformation state. What's being given to us is there is a sphere which is moving with V0, mass capital M, another sphere here. If you join the centers of sphere, this angle is alpha equal to 45 given degree. They have asked you to find loss in kinetic energy when the system is in maximum deformation state. When the system is in maximum deformation state. Now, before we go study for collision, I've told you collision means broadly what? Change in momentum. That is collision. Now, before we go in defining collision, let us try to compartmentalize collision. Collision are compartmentalized in two terms. First is based on energy. Please write it down. First is based on energy. Second is based on the manner that they collide. Second is based on the manner in which two bodies collide. By energy, what I mean is, if kinetic energy of system before and after the event remains, then it is called elastic, else inelastic. That is vis-a-vis kinetic energy read. Second one is based on the manner. Now, what do I mean by manner? Whenever two bodies collide, just before collision, what you do? You join their center of masses by a line. I repeat, what we do? We join their center of masses by a line. So we draw a line which will house center of masses of the bodies on the anvil of collision. Close on the heel collision. If this line is collinear with line of motion, if this line is collinear with line of motion, then it is called head-on collision or direct collision. If this line is collinear with line of motion, then it is called head-on collision or direct collision. Else oblique. Else oblique. Now, for one line to be collinear with the other line, first of all, we should have a common line of motion. For line of motion to be collinear with line joining center of masses, we ought to have common line of motion. If the line of motion per se is not common, then what kind of collision it will lead to? Obvious, oblique. So here, this is the line joining centers. This body is at rest. Only this is moving. So this is line of motion. Line of motion, or you can say common line of motion. And this is line joining the centers just before collision. What collision will this be, class? Direct or oblique?
Sir, oblique.
Oblique, correct? So when collision is oblique, then we look for same speed in which direction? Or we should say, we should look for component of velocity in which direction? Head-on direction. We will look for which direction? Head-on direction. Because deformation will take place in head-on direction. So maximum deformation in this case will be when the head-on component of velocity is common. Don't say that speed will be same. Speed will be same if and only if collision is head-on. Someone may ask you a question that, okay, maximum deformation means speed will be same. You will say no. Maximum deformation means speed will be same provided collision is head-on. If collision is oblique, then component of velocity in the head-on direction will be same. By which I mean here, maximum deformation means this will be moving with V common. V, this is V, and this one will have V common, this one, but V common. So far as this direction is concerned, this one was V0 sine alpha. It will remain V0 sine alpha. So, what about speed? Speed is Vc squared plus V0 squared sine squared alpha under root for this. And for this, it is only Vc. Therefore, these are very important points, class. Questions are asked on these. That's the reason I'm nudging. They may ask, maximum deformation state. Will the two bodies have same speed? What will you say? Depends. If it is oblique collision, they will have different speed. If it is head-on collision, yes, they will have same speed. I have one question for you, which is, two particles are colliding and one was at rest. Two particles are colliding and one of the two particles was at rest. What kind of collision it can be? Only head-on, only oblique, either head-on or oblique. Only head-on, only oblique, either head-on or oblique. What will you say? Two particles collide, one being at rest and the other in motion. This is complete acumen of yours, class. This is your IQ test in a way. Two particles collide, one at rest and the other in motion. what kind of collision it will be? Head-on, direct, either head-on or direct. Yes, please.
So if they're particles, then they'll have to be only point size, right?
Yes.
And so for a collision to occur, one of the particles must be moving directly at the other one.
Very good. Very good. Very good. So what will it be?
Head on.
Only head-on is possible. Good. And if both are in motion, dear?
If both are in motion, then
Then it can be either this way or this way, right?
yes,
So in this case, you will say it can be head-on or oblique, both.
yes, sir.
But if one is at rest, it's ordained to be head-on, correct?
Yes, sir, yes.
Okay, good, good, very good. Okay, so we'll further in the class to come, right, class? We are to be in touch. We have to keep on solving questions. Keep your questions coming as well. Okay? Right?
Yes, sir.
Yeah. Okay. My dear, take care. All the best for examinations. Pass with oblong. Okay? Let us serve the purpose we are in association. That is ranks. Right, class?
Yes, sir.
Okay.
Yes, sir.
Take care. God bless.
Thank you, sir. Bye, sir.
Thank you, sir.
Yes, sir.
Thank you. Bye. Save it first. Recording. You know or not? Stop recording then. Stop recording then. You still moving? I'm asking you, you're asking me. Must be saved, right? Stop recording.